when I look at this particular problem, the first thing I want to identify is what is the degree in the in the numerator? It is a 2. What's the degree in the denominator? So will there be a horizontal asymptote? There will be none, but there will be a slant asymptote. There will be a slant asymptote. We'll get back to that later. The next thing I want to do is, I wish I had done this in the previous problem, I want to see can I factor the numerator. So I'm going to take the numerator and I'm going to go off to the side. 2 times negative 2 is negative 4. Do I know two numbers that multiply to equal negative 4 and combine to give you a negative 3? I do. Those numbers would be negative 4 and positive 1. Now, I'm going to do this a little bit different way than what I taught you in September. This is my quick way of doing this. My quick way is take the selected numbers. Please don't talk when I'm talking. Take the selected numbers, and whenever there's a leading coefficient other than 1, I throw it underneath, and now I reduce. So I get x minus 2. But what do you do if you can't reduce? You push up, so 2x plus 1. Now, if you want to do the A, C plus B method in order to factor that, because that's what 100% of you voted on before, it would look like this. So I write down a 2x squared and a minus 2, and in the middle I write negative 2x plus 1x. And then I go, okay, I can factor out a 2x, and I get x minus 2. I write down x minus 2 plus 1. Please don't talk when I'm talking. They both contain an x minus 2. In front is a 2x, and back is a positive 1. And you get the exact same thing. So if you think, like, Miss Bradley, I really prefer this method, then go for it. That's okay. As long as you get to this point, it doesn't matter how you factor. Okay, I'm going to rewrite this right now. G of x equals x minus 2. 2x plus 1, that's in the numerator. The denominator is x minus 1. I'm going to make myself a very simple graph. In order to figure out the vertical asymptote, I'm going to take the denominator and set it equal to 0. What I want you to get out of the habit of doing is write the vertical asymptote is 1. It is an equation. It's x equals 1. So I'm going to go on my graph to positive 1, and I'm going to make a dotted line representing the vertical asymptote. Before I figure out the slant asymptote, I'm going to go ahead, because it's in factored form, it's easy for me, and I'm going to take each one of these quantities and I'm going to set it equal to 0. That will determine the x-intercepts. In the numerator, if there's a variable, that's how we determine the x-intercepts. So 2x minus 2 equals 0, okay, that means one x-intercept is at 2. Then I'm going to take 2x plus 1, set it equal to 0. I first subtract 1 to the opposite side, I divide by 2, and I get a negative 1/2. Negative 1/2. Okay, I have my x-intercepts. Let's figure out the y-intercept. Let's figure out the y-intercept. Your y-intercept, we come back up here, we plug in 0 for x, we plug in 0 for x, we plug in 0 for x, and negative 2 divided by negative 1 is a positive 2. My only thing I still have to do is the slant asymptote, and I am done. How do we figure out the slant asymptote? We're going to divide this. So let's go down below where I have a little bit of space. And I think I could do it right in here. And I'm going to make my division box. The numerator always goes inside, and the denominator goes outside. Please don't talk to us. If you are new to long division, then I definitely would suggest you make these lines. Each one of these will represent a different variable. So this is x squared, this is x, and this is the constants. This class has strong math abilities. I think I can just verbalize. X times what is 2x squared? I distribute, I change the sign, and now I'm going to add down. So change. When these combine, I get negative 1x. I bring down and I start the whole process again. X times what is a negative 1x? Negative 1. I distribute. I change the sign of both. Now remember, with polynomial long division, as it applies to slant asymptotes, blah, 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 I don't care about the remainder. This is all I care about. This is the equation that I'm going to graph for a slant asymptote. If you need a reminder, that means I start at negative 1, and I go up 1 over 2. So I start here, I go up 1 over 2. Sorry, my fault. I start at negative 1. Ooh, I almost did that wrong. I start at negative 1. Let me switch this up. Oh, goodness, that was close. I start at negative 1. I go up 2 over 1. Up 2 over 1. Up 2 over 1, and vice versa. Down 2 over 1. So this is going to be my slant asymptote. I now on the graph have my slant asymptote. I have my x and y intercepts, and I can see what this looks like. It gets closer and closer to both asymptotes. Oops, sorry, this should be coming in like this and back over here.